Today we're talking about graphing systems of linear equations. Linear inequalities. We know what inequalities are. What are they? Good. You have like your less than and greater than signs, which means what do you do once you make your line? You shade it. Very good. Okay. So now when it says systems means you're going to have multiple lines and multiple shading. Okay? Your solution is the overlapping shaded area. Do you guys remember this from Algebra 1 a little bit? Not really. Okay, well, we're going to hopefully remember it once we do this today or learn it. So again, your answer is always the common shaded region. Similar to yesterday. If you want to check if a point is a solution, if it works for one, that's great, but in order for it to work, it has to work for both of them. If you get a false answer right away, like if I plug this in and it doesn't work for the first one, I don't even have to try the second one because it has to work for both no matter what. Okay? So let's start with A together, and we are going to check to see if 3 over 2 is an answer. What is the other way, though, I could have found the answer besides plugging in? Graph it and check if the points on the overlapping part. Good job. Okay, so we plug in our x and y value. So I have 4 times 3 plus 2 times 2, and I am checking to see if it is greater than 6. What is 4 times 3? 12. Plus 2 times 2, which is? And 12 plus 4 is? Is 16 greater than 6? True. Okay, that one works. Okay, now we take this point and we're plugging it into the second equation. So on this one, we're going to have 2 times 2, and we're checking to see if that is greater than 3. Is 4 greater than 3? So it's true. So your answer, you would say, is yes or true, or however you want to write that. So yes, 3 over 2 is a solution to this system of inequalities. So this point, 3, 2, is an answer. So this point is in the shaded region of these two lines. So we plug these values into the first one.
Yeah, where did it go?
So 3 goes in for x and 2 goes in for y.
Like that.
Okay, and so 16 is greater than 6.
Got that.
So with systems, you have to check it on the second one too. So here I plugged in 2 for y and 3 for x. We're good? Okay, so B, you're on your own. Thumbs up, it's true for both of them. False, it doesn't work. So either this point is going to work or it's not. Okay? Good, 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 good. You guys are amazing. Perfect. Thumbs up, you got the right answer. Sorry. Good. Okay, so if you plugged it in correctly, you should have got the first one was false. So the answer is no, it's not a solution, or false, either way. So I'm going to plug this in to show you in case you got true for some reason. We have 4 times -1 plus 2 times 4, and then we're checking to see, is that greater than 6? 4 times -1 is? And 2 times 4 is? 8. -4 plus 8 is? 4. Is 4 greater than 6? No, it is not. Okay, so that means this answer is no. -1, 4 is not a solution to the systems. Okay, are we good? All right, moving on, graphing. We talked about graphing yesterday. Graphing is the same with systems, except for you have multiple lines and shading on the same graph. So we need to remember that the line is solid when it has your greater than or equal to or less than or equal to, and your line is dashed when it's just less than or greater than. Okay, So let's go down here. So I'm just going to make a little point here. I'm doing this line in red. So y is less than or equal to 3. Where will I go to graph this line? Where will I go? Up 3, because it's positive. Positive's up. Up 1, 2, 3 on my y-axis. Remember, this is your y-axis. This is your x-axis. Okay, is this going to be a solid or a dashed line? Solid. So we're going to go ahead and make our solid line. Hopefully you can draw yours better than I can draw mine. And then shading. This is saying y is less than or equal to 3. Which way does less than shade? Down. If you think about it, smaller numbers are down, right? So we shade down. Are we okay with me not testing a point? Yeah? Okay. Is this line in y equals mx plus b form? Yes. Okay, so whenever I'm graphing, I need to know what two things? M and B. Very good. What is my M value for this problem? Very good. 2 over 1, because we always want our rise and our run value. And B is 7. Okay, where will I go first? Very good. Up 7. So this is 3, 4, 5, 6, 7. Make a point. From there, we use our slope. How do I do my slope? Up 2, right 1. We could have also done negative, negative, negative 2, negative 1, because 2 negatives make a positive. Okay, is this going to be solid or dashed? How do we know it's solid? Because of the equal to line. Very good. Greater than or equal to, which way does that shade? Up. So it's up. It's above the line. Okay? Do you notice where the lines are overlapping or the shading is overlapped? It's this area. So it's always a good idea to make that part just a little darker so it stands out and your answer is known right there. If you were taking a multiple choice test, they wouldn't have all of the shading. They would only have the overlapping shading. So you would choose the answer that looked like that. Are there any questions on this example? Oh, just for fun. You don't have to. Sometimes like the graphs where like you'll end up at at this point, and instead of trying to make it go off the graph, I'll do like the opposite so that it's on the graph, but it doesn't matter. They only need 2 points. Okay. Moving on. All right. Okay, example 3. What is different about this one? It has 3, which makes it a little bit more difficult when you're shading and stuff. You have to be careful that you notice where the shading is. And that's why I think colors are good, but however you do it is fine. So, x is less than or equal to 6. Where do I go? Where? Right 6. Okay, because this is our x-axis and this is our y. So on the x, we're going 6. 1, 2, 3, 4, 5, 6. Is this solid or? Thank you. Okay, less than. Do we think less than will shade left or right? Left. Okay. We can't really do down and up when it's a straight up and down line, right? So it's just going to be left because our negative values, our smaller values are left, which would make sense with less than. Okay, next line. Y is less than or equal to 5. Where will I go? Where? Up, because it's positive. Up 1, 2, 3, 4, 5. And we have our horizontal line. Is it solid or dashed? Very good. And again, Y? Perfect. And which way will I shade on this? Down. Okay, so we can see the overlapping area right now. Okay, but we need all 3. So we're not going to shade anything really dark yet until we get to our third line where we can see where everything is overlapping. Is this in the correct form right now?
Yeah.
Good. Yes, it is. So now all we need is our 2 pieces of information. What do we always need to know when we're graphing? Good. M and B. What is my M value? Good. Remember that if there is no number in front, there's actually a 1 there. And we can write 1 as a fraction by putting it over 1. Our B value is what? 3. What do we graph first? 3. And where do I go? Up 3 is correct. 1, 2, 3. Make a point. From there, where do I go? Good. Up 1, right 1. Or I could have gone down 1, left 1, because negative, negative really means positive. Solid or dashed? Solid. Okay, so this line, greater than, which way will I shade? Very good, up. Do we see where all 3 are overlapping? Good, it's kind of this triangle over here. So I'm just going to shade that in a little darker. And we are done. Yes?
So if you plug in 0, 0 to it, it says that y would be greater than
0. Right, which is why you need to shade on this side. Good. You're thinking good little things. Yes? Sure. As long as it's obvious, that's all that matters. Okay, example 4. Oh, were there any other questions on 3? Or anything in general? Okay, 4 is a little more complicated. Why is 4 more complicated? All of them need to be put into slope-intercept form. None of them are in slope-intercept form, so it's just a mean problem, but that's just the way it is. Okay. Actually, it just makes it more fun because you get to do all this math work, and math is awesome. Okay, x plus y is less than 4. Now, some of you are very intelligent and can do stuff in your head. It is okay to do some things in your head, okay? For instance, I know that we have to subtract x to both sides. So I'm sure some of you in your heads know that you can just write y is less than negative x plus 4. If you can do that in your head, I'm okay with that. You don't have to show the subtracting x part, okay? All right, so that's done. What do we need to know to graph this line? Oh, we always need? Sorry, m and b. I just said that different, sorry. M equals and b equals. What does m equal on this problem? Very good. Negative 1 over positive 1. And my b value is 4. Where do I go first? Sorry. Good. Up 4 on the y-axis. Again, remember y-axis, x-axis. So 4, we go up 4. 1, 2, 3, 4. Make a point. From there, where do I go? Down 1, right 1. Perfect. Is this line going to be solid or dashed? Very good. Shading. Less than. Which way? Down. Very good. Okay, this next one's a little bit more complicated. I'm going to give you about 15 seconds to try to write it in y equals mx plus b form on your own. Okay, so you should have gotten y is less than 2x plus 1. Okay, I'm going to go ahead and show you. You need to subtract 2x to both sides. From there, those cancel. Don't forget there is a negative in front of the y. Negative y is greater than, and what will I write first? Good. Negative 2x minus 1. From there, I still have the negative in front of the y, so what do? Divide by negative 1 to everything. Those cancel, 2 negatives make a positive. What happens whenever I divide by a negative? Good. So we have y is less than. Again here, 2 negatives make a positive, so I have 2x. And again, 2 negatives make a positive, so a plus 1. Again, we need 2 pieces of information in order to graph. What 2 pieces do I need? M and B. What is M? 2 over 1. Perfect. What is B? 1. Where do I go to plot my first point? Up 1. Make a point. From there, I go up to right 1. I'm on that same point there, so maybe I'll do another one just so I can see it better. Up to right 1. Is this line solid or dashed? Oh, very good. Okay, and shading. Again, pay attention to once it's in y equals mx plus b form, because our inequality sign flipped, didn't it? So less than, where am I going to shade? Below the line. Very good. Okay, so right now I can see the overlappings right here, but we're going to see once I get this last line. So I have negative x plus 5y is greater than negative 15. First thing I'll do is add x. Now I have 5y is greater than x minus 15. Next step is to divide by 5. We get y is greater than, remember to always kind of pull your m value in front. And this isn't 5 I'm pulling in front, what is it? 1/5, because there's really a 1 in front. So this is 1/5 x, and then negative 15 divided by 5 is negative 3. Good. I need 2 pieces of information. I need my m and my b. What is my m value? 1 over 5, and what is my b value? So on my graph, where do I go first? Down 3, 1, 2, 3. And from there I go, good, up 1, right 5, 1, 2, 3, 4, 5. Or again, I could have gone negative 1, negative 1, 2, 3, 4, 5. Solid or dashed line? Wait, I did something wrong. Did I? No? Okay, just kidding. Solid or dashed? And shading. I'm going to shade up. Can you see where they overlap? So here is my blue line and my red line and my black line right in here. Okay, any questions? Example 5, we see decimals. But guess what? We can get rid of decimals. Who remembers how to get rid of decimals? Nobody remembers? Okay, up here on my wall, way up high, you'll see a decimal point. Okay, one place to the right of the decimal point is the what place? Tenths place. Good. 2 places is the hundredths place. Now you look in the problem. There is only one number behind this decimal, one number behind this one, and none behind this one. So if I multiply by 10, because it's the tenths place, I can get rid of all of my decimals. But again, like when we're getting rid of fractions, we have to multiply every term by that number, whether or not they have a decimal or a fraction, right? So I'm going to multiply every single term by 10. When I do that, this one I can move the decimal place and get a 5. This one I move a decimal place and get a 2. This doesn't have a decimal place. You can add a decimal and move it, or 2 times 10 is 20. So just make sure you do that. So I have 5x plus 2y is less than or equal to 20. Where do you think students mess up? Right, they end up writing this as 2. They forget to multiply the 10. That will mess everything up. Okay, what is my next step on this problem? Good, subtract 5x. 2y is less than or equal to negative 5x plus 20. Next step is what? Divide by 2 to every single term. And we get y is less than or equal to negative 5 over 2x plus 10. What two pieces of information do I need? M and B. Go ahead and do that. This Mrs. Alto. Yes. Okay. Yes, yes. Can you give me like 5 minutes? Okay. Okay, thanks. Bye. All right, so hopefully you had a chance to graph this on your own. M equals negative 5 over 2 and B equals 10. There's exactly 10 lines on here. So we're going to go up 10 and make our point. From there, you should have gone down 1, 2, 3, 4, 5 and write 2. Solid or dashed line? Very good. And again, why is it solid? Good. It has that equal to line. And less than or equal to would be shading down. Okay. Next line, hopefully, maybe you've already done this, is just our 2. So x equals 2. Where do I go? Right 2. Our line goes up and down. Is it solid or dashed? Solid. Very good, because it has that equal to sign. And greater than, will I shade to the right or the left for greater? Which way it has positive, bigger numbers? Greater would be positive and bigger. To the right. And again, you can always test points if that doesn't make sense to you. Okay, the last line here we have is y is greater than or equal to 3. So we're going to go to y equals 3, which would be which direction? Good, up 3. Solid or dashed? Solid. And again, it's solid because it has the equal to sign. Very good. And greater than. Which way is greater than shaded? Up. Do you see that little tiny triangle where they all overlap? It's right here in the middle. Yours is smaller, so it's harder, but it's just right there in the middle. Are there questions?